Welcome to vpod.ai. This deep dive is sponsored by Stonefly, a leader in enterprise storage, backup and disaster recovery, AI storage, and cloud solutions. If you are looking for secure, ransomware-proof storage, then Stonefly sells air-gapped and immutable storage. Contact sales at stonefly.com to schedule a demo.
So for decades, robotics, it always felt like science fiction, right? Something like 10 years away, forever, Rosie from the Jetsons doing the housework. But it just seemed too expensive or maybe too clumsy for the real world. Now, though, we're seeing literally billions pouring into the sector. And the feeling is this robotics revolution, it's finally ready to, explode. Our mission today is really to understand why now. What are the core things driving the shift from just theory to actual commercial products?
It really is an inflection point, and you nailed it. It's about integration. It's not just one flashy robot. The breakthrough is that the whole ecosystem, everything you need for these complex adaptive machines, it's finally here. It's complete. We've kind of boiled it down to three key parts that have to work together for this to really happen. Okay, let's lay that groundwork then. What are these three sort of foundational ingredients for a real robotics industry?
Yeah, we can keep it simple. First, there's the physical. That's the hardware, the actual bodies, the machines. This is the part we've had the longest, right?
Yeah.
Industrial arms, things like that, been around for ages. Second, you absolutely need the muscle. This is the power source. Think rare earth elements, powerful magnets, good batteries, things that give it strength and, crucially, precise motion. And then the third piece, the one that's really changing the game now, is the brains. This is the AI, the software layer. It provides actual intelligence, perception, decision-making. The big aha moment, I think, is that while we've had bodies and, decent power for a while, it's this intelligence layer finally maturing that turns rigid tools into, flexible partners.
Okay, let's definitely start there with the brains. Because that intelligence, that's what feels truly 21st century, doesn't it? Not just automating old factory tasks. It's the chips, the software platforms, the learning, the ability to adapt when things aren't perfectly predictable.
Exactly. That intelligence is vital for seeing the world in real time, navigating accurately, and maybe most importantly, learning. Think about the difference, right? An old robot arm doing the same weld over and over versus a modern system you can train in simulation. Then it goes out and recognizes new stuff, different environments. It shifts the whole thing from just automation to smart collaboration.
And the point of that intelligence ultimately is hitting precision and accuracy that humans just can't consistently manage. Which I think brings us neatly to a company like Trimble. For people who don't know, what's Trimble's role here? How are they using this AI-driven intelligence?
Right, Trimble, ticker TRMB. They're all about enabling precision GPS and positioning tech. They talk about centimeter-level accuracy, which is just staggering, really. When you get that precise, you start removing basic human error from tasks needing total consistency, like construction, farming, surveying.
Let's stick with construction for a second. If you're building, say, a big skyscraper or even just a housing development, how does that centimeter accuracy change the actual project, the cost, the time?
Oh, it cuts waste massively. And time, obviously, is money. Think about running pipes or electrical conduit. If a human measures slightly off, even just a little bit, everything that comes after, the framing, the drywall, the concrete, it all has to compensate. That's wasted material, wasted time, expensive fixes. Trimble systems mean that prepping a field or setting that first foundation or even placing drywall, it gets done with machine perfection. Less rework, much less.
So it's not just about maybe replacing labor, it's doing the job fundamentally better than a person could, no matter how focused they are.
That's the core commercial advantage, yeah. The machine doesn't get tired, doesn't have an off day. These things can run 24/7, rain or shine, daylight or not. Doesn't matter. And importantly, this isn't just future talk. Products like their S5 and SPS 720 total stations, they're already out there in use commercially for surveying, construction, providing that super fast, super accurate measurement right now.
Okay, so the intelligence is becoming really powerful. But that brain needs a body, right? Let's shift to that second piece, the bodies, the actual physical hardware.
Right, the machines themselves. And they come in all shapes and sizes. Could be drones, could be highly specialized manufacturing tools, even defense systems. The main drivers here are really about deployment, getting these systems out into the world to fill labor gaps, or maybe do jobs that are just too dangerous or physically demanding for people.
And I think the most compelling examples are where the robot works with a person, but takes out that potential for human error or fatigue.
Yeah.
Healthcare comes to mind. Intuitive surgical.
Intuitive surgical, yes. ISRG. Their Da Vinci systems are a perfect example of this cobot idea human-robot collaboration. They're in, over 8,000 hospitals now globally. They allow for minimally invasive surgery, which is amazing in itself. But the deepy thing, I think, is how the tech shields against basic human physical limitations.
Tell me more about that. I seem to remember reading something about surgeons and, well, needing steady hands for incredibly long procedures.
That's exactly it. The robot essentially acts as a perfect, steady filter. A surgeon, might sometimes need something like beta blockers just to keep their hand perfectly still, calm nerves during a tough, maybe 10-hour operation. The robot, it has no tremor, none. It delivers consistent, precise force, and it never gets tired. This frees up the surgeon, who's still fully in control, mind you, to focus purely on the strategy, the decisions, while the robot handles the flawless execution.
And from a business perspective, Intuitive Surgical built a really smart model there. It's not just the big, expensive machine up front.
Right.
It's locking in that recurring revenue from all the specialized tools and supplies needed for every single operation.
Yeah, that creates a really strong competitive advantage, a moat, as they say.
Okay.
Now, if you look at the stock, ISRG, like a lot of these high-growth tech names, it can be volatile. It bounces around. And that makes people ask, well, if the tech is so good, why isn't the stock just a smooth line upwards?
That's a fair question, especially if you're focused on the technology itself. Why doesn't clearly superior tech mean smooth sailing for the stock price right away?
Because this whole robotics revolution, we're still in the very, very early innings. The market is constantly trying to figure out how fast this stuff gets adopted, right?
Yeah.
And it reacts to things like quarterly earnings, economic slowdowns. But if you zoom out, connect it to the big picture, you have to realize this is likely a 10-year, maybe 20-year megatrend driven by AI. So short-term bumps are going to happen, but the potential for these foundational companies to maybe grow 50, even 100 times over a decade, that's real. You're watching a huge transformation unfold, not just a single product launch.
That long-term view seems critical. Okay, we've got the intelligence, the brains, we've got the structure, the bodies. Now, the final piece, and maybe the trickiest one, the muscle.
Mm-hmm.
Without reliable power, reliable movement, these amazing systems are just, smart statues.
The muscle is definitely the toughest part, I agree. And it's where a lot of the geopolitical tension comes into. This is all about the raw materials, specifically those high-power, high-precision magnets and the batteries needed to run everything. And these magnets, they're not just about raw strength. They're essential for the incredibly smooth, instantaneous control over movement, the torque that you need for something delicate like surgery or even just navigating a cluttered site.
And getting that super precise movement depends on very specialized stuff, right? The rare earth elements.
Precisely. We're talking elements like neodymium, specifically neodymium iron boron magnets. They're crucial for making these magnets incredibly powerful but also compact. The challenge here is just scale and scarcity. Think about it. A single humanoid robot might need, say, 2 to 4 pounds of these rare earth magnets. Now, if projections are even close to right, and we might need billions of robots by mid-century, the demand is just astronomical.
And the supply chain for this stuff is notoriously slow to build out, isn't it? Takes something like 16 years to get a new rare earth mine fully productive.
About that, yeah. 16 years from finding something promising to actually having a productive mine. So you can't just flip a switch when demand spikes. And that leads directly into the geopolitical risk. Right now, China really dominates the mining and, importantly, the refining of rare earths. For governments like the U.S., especially thinking about defense applications, advanced drones, precision weapons falling behind on a secure domestic supply, that's a huge national security concern. So we're seeing immense pressure, potentially massive funding, aimed at building up that domestic supply chain.
Which brings us to a key company here, MP Materials, ticker MMP. They're actually running a U.S.-based rare earth mine and processing facility. What kind of dent are they making in this global picture?
Right. MP Materials operates the Mountain Pass mine out in California. They account for maybe 15% of current global rare earth output, something like that. And crucially, they're working towards doing the whole process domestically, right up to finished magnets. They're already supplying really important buyers, saying Tesla, GM, and yes, the Pentagon.
Let's circle back to something you mentioned earlier about the economics.
Yeah.
You used the phrase unlimited inflation for the cost of these materials for the companies buying them. That sounds pretty dramatic. Why is the demand quite so extreme?
It really boils down to two things: necessity and time. First, for these high-performance motors and EVs, wind turbines, advanced robots, there just isn't a good, cheap substitute right now for these specific magnets. Demand is inelastic. Tesla, Intuitive Surgical, they have to have them, period. Second, like you said, that supply is basically fixed in the short to medium term by that super long mining timeline. So you've got demand rocketing upwards from multiple huge industries, EVs, defense, robotics, while supply is constrained and geographically concentrated. The result, the price for the companies that need these materials faces sustained, massive upward pressure. They basically have to pay whatever it takes, because the alternative is not building their product at all.
That really positions the raw materials piece as essential and a high-growth area, even if it's not the most glamorous part of robotics.
Exactly. And when you put it all together, the brains like Trimble, the bodies like Intuitive Surgical, and the muscle like MP Materials, what really stands out is while these are fantastic growth stories already, we also need to be really clear about the big challenges, the hurdles that are going to drive the next wave of innovation.
Okay, good point. Yeah. What are the, say, two biggest unsolved problems right now that someone following this space should really keep an eye on for future breakthroughs?
I'd say number one is battery life. Definitely. The current standard for a lot of complex robots, maybe 2 to 4 hours on a charge, that's just not enough for serious commercial use. If a robot's supposed to cover an 8-hour human shift, but it needs 2 hours to recharge after only working for 3, well, the productivity math doesn't work out so well. We need a serious leap forward, either much faster charging or just way better energy density in the batteries themselves.
Makes sense. And the second big hurdle, based on our chat about MP materials, has got to be related to those rare earth, right? The supply chain.
Absolutely. The second huge problem is finding substitutes. Given the scarcity, the cost, the geopolitical issues around rare earths, there's an enormous incentive, financial, strategic, for brilliant scientists, probably using AI to speed things up to find other more common materials, something that can deliver that same magnetic power and precise control without needing neodymium or those other rare elements. If a company cracks that code, finds a cheap, effective, non-rare earth substitute for these supermagnets, that would completely reshape the global supply chain. Huge disruption, massive returns. That's definitely something to watch very, very closely.
Wow. The potential for more innovation across all three layers, brains, bodies, muscle, it really is enormous.
And if you just connect it back one last time to that bigger picture, remember the kind of potential we're talking about. These core companies, they're riding a massive wave. They seem poised for really extreme growth over the next decade. These early stages, fueled by AI, huge infrastructure needs. It almost feels a bit like that mega melt-up we saw in tech back in the late 90s, early 2000s. Foundational tech changing everything.
Definitely keep that long-term potential in view. Think 10 years for these foundational plays, not just next quarter's earnings. Focus on the whole ecosystem. We really appreciate you joining us for this deep dive into the three core components driving the robotics revolution. And remember, if you're looking for secure, ransomware-proof storage solutions, Stonefly is a leader in enterprise storage, backup and disaster recovery, AI storage, and cloud solutions. They offer air-gapped and immutable storage, perfect for protecting your critical data. Contact sales at stonefly.com to schedule a demo today. Thanks for listening. We'll catch you on the next deep dive.